Alright, so how to use malloc and dynamically allocate memory in C. Let's find out. First thing that you have to do is include a certain library, and that library is called mem.h. Alright, make sure you include this. We need this for a certain function that we're going to be using in shortly. Okay, now you have to decide what type of variable you want to allocate dynamically. So let's try to dynamically allocate memory for one integer, just one integer, right? So we have to declare a pointer to an integer, right? So just int star, and let's call it p from pointer for simplicity. And what we're gonna initialize this p with is from the return of a function, and that function is called, well, guess what? malloc. And this function takes in the number of bytes you want to allocate on the heap, and it returns a pointer at the start of that address. Alright, so in our case, what do we want to allocate? Well, we want to allocate an int, so we are going to get the size of that int using the size of operator. So just type in size of, and in parentheses say int. Alright, so this will usually return 4 bytes. Usually int is in 4 bytes, but in some cases it can be on 2 bytes or even 1 byte. Alright, so after that's done, one more thing to avoid certain warnings is we have to cast the return to our own type. So let's cast this to an int star. Alright, now that we have the pointer to that address, we can use it however we want. Alright, so to do this, let's try assigning the value inside that address to be 5, for example, and let's print that value. The value is, well, whatever we gave it here, and just star p, and star p stands for dereference the pointer p. Basically gets the value to which p points. Alright, and one critical thing you have to do for each malloc is you have to free that memory, because it's dynamically allocated. It's no longer on the stack, and no longer gets automatically thrown away by the operating system, by the compiler. So what you have to do is tell it whenever you want to free that memory so that somebody else can use it. So at the end of our program here, we're going to call a function called free, and inside there we give it the pointer that we want to free, and just that. That's all you have to do. So malloc the amount of memory in bytes that you want to allocate, and then just free whenever you're done with the memory and somebody else can use it. Alright, if we try to run this, hit F11, you will notice that we get the value is 5, because we have in fact allocated the memory on the heap, and it all works together. Alright, one more thing I want to touch upon is, well, you can, using this method, you can actually declare arrays of integers the same way you would declare just one integer. Well, all you have to do is just type in, instead of size of int, however many integers you want to allocate. For example, I want an array of 3 integers. Alright, and I can reference that those values just like I would be doing it with arrays. So in our case, I say p of 1, let's assign that the value 3, and let's say p of 2 is value 90, for example. And I can just print them like so. Let's see, the values are that and that. I'm just going to print p of 1 and 2 because those are the only ones that I assigned value to them. And now if I try to run this, you'll notice that we get the values are 3 and 90. Well, let's take a look at the first integer in our array. So let's print that on the console as well. Let's say %d and just add it at the beginning here. so that it's all nicely formatted. If I try to run this, you'll notice that the values are 5046608, which means that the memory that we allocated didn't get set to 0, it didn't get initialized. So whatever was there, it just kind of was already set. So to prevent this, there's another function that you can use. Instead of malloc, you can use, let's see here, you can use a function called calloc. And calloc is a function that also allocates memory on the heap, so dynamical memory, but it sets all the allocated memory to 0. All right, and this is a little bit different. You have to specify the number of elements and the size of element. And well, the simple thing to do here is just type in, for example, 3 in our case, and we want 3 of what? Of integers, so 1 3 times 4 here, and it's just gonna do the multiplication for us. That's the only difference, and the fact that it initializes it to 0. So now if I try to run this, you will notice that we get the first value 0, and in fact every single value in there was 0 at one point. So I hope you understood something here, and thanks for watching.